myself Priyanshu, and my team members are Sneha Kadambala, Atar Khangar, and Shreyas Satri. So our B project is demystification of neural network through explainable AI. So our project mentor is Professor Sangeeta Oswal ma'am, and our group number is 16. So our project is basically nowadays all the MNCs are using ML model. So they are taking certain input and feeding it into a ML model, and they are getting certain output. So how exactly the model is working? So the model itself is a black box. How internally it is, what parameters internally it is considering, it is not known to other people. So through explainable AI, we are trying to visualize that data as well as with the help of NLP, we are giving a what parameters the model is internally considering for predicting that particular output. So our problem statement is basically with the help of explainable AI, explainable AI techniques, we are providing the visualization as well as through NLP, we are providing them the solutions like what are the parameters, like how they should trust on our ML model. So the main objective is to basically ease the process and automate the whole process where it will basically predict in the human readable language where the user can be easily can interpret what the ML model, like what parameters the ML model is considering, and it increases the transparency between the users as well as the model. So the flow diagram of our project is basically we have took the data set of SWAT data set. It is a water treatment plant data set. So this data set is basically passed into the TCN autoencoder architecture. And through TCN autoencoder architecture, the second part, which is basically explainable AI. So the explainable AI have two parts. The first one is visualization, and the second one is NLP. So let's start with the data set. So SWAT data set. So it has 53 sensors in it, and the sensors is divided into the six class, and each class have five or six number of sensors, and these sensors are taking the time series data sets continuously, and this data set is collected of 11 days data set, which we are using for the training of our model, and it has the number of features 51, and the number of records which we are using for training our model is 4,95,000. So this is the six different classes which you can see here, like the P1, P2, P3, P4, P5, and P6. And these different classes have numerous number of like a different number of sensors which is collecting the real time data of the sensors. So coming to the second part is the model which we have used here is basically here we have used temporal convolution network. So we have not just used the TCN architecture, we have used a TCN with autoencoder. So why we have used TCN here? So basically it reduces the computational power. So with the help of dilution factor, it reduces the computational power of the ML model. So this is the whole architecture of our project. The first part is encoder, and the second one is decoder. So as we saw in the system architecture, the encoder part take the input and encode it into the uh, tensors, and that particular data we are again we are decoding and generating the output again. So this is the overall system architecture. We are taking the data, we are passing it into the TCN autoencoder, and after flattening the data, like the external AI part comes in. So where we are basically visualizing the data as well as we are using the NLP to explain that data, like the explain the problems which we have detected in the model. So these are the parameters and the accuracy of our model, the precision, recall, F1 score. So the second part of project, which is explainable AI. So here there is two section, visualization and NLP. So in the visualization, we are using SHAP model for basically SHAP model basically gives the values how much each attribute is contributing in the prediction of the model. It gives a positive as well as the negative value. Positive means it is creating the positive impact in the prediction of the model. Negative value is indicating that it is creating the negative impact in the model prediction. So this is the graph which we have got after using the sharp visualization. So here we can see these are the 51 sensors in the left side, and based on, as we have used here the data set of anomaly data, so it is predicting the values which is less than zero, like all the values are negative, and the upper part of the sensors is the it is showing top to bottom the importance of the attributes. So the FIT 101 basically it is contributing more in the prediction of the model. So next come to the NLP section. So basically we are taking that sharp values, and with the help of sharp values we are converting in, we have created a dictionary. So wherein basically we are, with the help of that sharp values, we are taking the average mean value of that particular class, and we are giving into uh, a human language, like what are the problems and what are which sensor is facing the issues. So here we can see is which is the most important feature, which is attribute, which is creating the positive impact, as well as we have also displayed the sensors which is having a negative impact on the model. So the tech stack which we have used is Python libraries and IDE, Jupyter Notebook, as well as we have used the cloud for training the model. So now let's take a look of the working model of the project. So here we have took the data set. So this is the libraries which we have used here is pandas, numpy, matplotlib, seaborn, torch, utils, and we have imported the decent autoencoder architecture. So this is the basically the architecture and the internal configuration of the decent autoencoder. And here we are loading the SWAT data set into the variable normal. So this is the 51 census data, and at the end we have to predict which is whether the input is normal or it is attacked. So these are various steps which we have did, and we have converted the 2D data set into the 3D data set, as we have designed the model which is taking the 3D input. So this is the training process, or this is the training process of our model. So we have trained our model uh, on TCN autoencoder architecture. So this is the trading and validation losses versus the number of epochs which we have took during the training of our model. This is the box plot we have which we have plotted for the model. And here comes the main part. So the precision, recall, and F1 score which we have got in our model, and this is the ROC curve. And this is the distribution of anomaly scores which we are displaying here. Now the second part is basically the anomaly detection. So here, as you can see, MV101, FIT101. So these, it is showing the importance level of these sensors. So it is contributing more in the model predictions. From the top to bottom, the importance level of that particular sensor is decreasing. And here, as you can see on the x-axis, it has positive as well as the negative values. The positive values means it is contributing positively in the model contribution, and the negative values, it is showing that it has negative contribution in the model prediction. So these are the shaft values with the help of which we have just plotted that diagram, the graph which we have seen. So this is the cumulative importance of the feature. So this is the main part of the NLP. Here, basically, we our data is basically under the six classes, which is raw water, pre-treatment, ultrafiltration, dechlorination, reverse osmosis, RO product. So in each classes there are 4 to 5 sensors or more than that. So we have created the dictionary, and based on that SHAP values, we are taking the SHAP, the average mean of that SHAP values of that particular class, and if it is greater than certain threshold, then it has certain problems. So So here we have also defined what kind of problems the sensors can face in the dictionary. So it if the average value of that particular class is greater than certain threshold value, then this dictionary will be triggered and it will display like what are the problems that particular sensors and which sensor is facing. So as we can see here, features like what of raw water, like fit 101 lit 101, how it is contributing to the model. That's all. Thank you everyone.